Welcome back. This is Nikkei Graham. I will be discussing exponential equations using logarithms. I think it's only one video for this. I will be giving examples, only examples. Okay, consider the equation 2 raised to x is equal to 30. Solve for x, giving an exact answer by using base 2. We always remember that if we have a or b base raised to x, that is equal to y if and only if x is equal to logarithm of y with a base b. So that means this one now if we transform this now, we have 2 raised to x is equal to 30. This is my b, this is my x, and this is my y. That means we have x is equal to logarithm of 30 with the base 2. How about if we're using base 10? Then we need to follow this law of logarithm. Then we have 2 raised to x is equal to 30. Then we have, according to the last, we have x logarithm of 2 is equal to logarithm of 30. And it is base 10. We don't need to give the bases. And then if we divide both sides of the equation by logarithm of 2, then we have x is equal to logarithm of 30 divided by logarithm of 2. I have a lot of students who will answer this logarithm of 15. That is not right, because the value of logarithm of 30 divided by the value of the logarithm of 2 is not logarithm of 15. They are not the same. So if I'm going to show that, here's my calculator screen. If you are wondering which calculator I am using, then I am using Casio FX9750G2. Okay, if we're going to use logarithm of logarithm of 30 divided by logarithm of 2, that is 4.9, and then we say logarithm of 15, that is 1.17. They are not the same. So always remember that logarithm is of 30 divided by logarithm of 2 is not the same when you divide those numbers. Okay? And then take the logarithm. It's not the same. Remember that. Okay. Another. We have find exactly. It's here. And then we have the base is e. That means we're going to use the logarithm, the natural logarithm. So for a, we have e raised to x is equal to 30. Then we have x ln of e, because of this law, is equal to ln of 30. And we know that ln of e is 1. Then we have x is equal to ln of 30. Okay. And then for b, we have 3 multiplied by e raised to x divided by 2 is equal to 21. Then we have someone came. Okay, let's continue. If I'm going to divide both sides of the equation here now by 3, then we have this one is equal to 1. Then we have e raised to 2x at raised to x divided by 2, not 2x, is equal to 7. Then we have x divided by 2, ln of e, is equal to ln of 7. This is 1. Then we have x divided by 2 is equal to ln of 7. And if we multiply both sides of the equation by 2, then this will become 1. Then we have x is equal to 2 ln of 7. Okay. Next is consider the equation p is equal to 200 multiplied by 2 raised to 0.04 t. Rearrange the equation to give t in terms of p. Then we need to have t is equal to something. Okay. So if I'm going to write down p is equal to 200 multiplied by 2 raised to 0.04 t. If I divide both sides of the equation by 200, that is 1, then I have p divided by 200 is equal to 2 raised to 0.04 t. And then if I'm going to find the logarithm of both sides of the equation, then we have logarithm of p divided by 200 is equal to 0.04 t logarithm multiplied by logarithm of 2. And then if we divide both sides of the equation by 0.04 multiplied by logarithm of 2, then we have only t now here. Both sides, sorry. 0.04 multiplied by logarithm of 2. I forgot to write. And t is equal to, I will write here. T is equal to logarithm of p divided by 200 divided by 0.04 times logarithm of 2. So if we're going to do the b now, when p is equal to 6, and then we have t is equal to logarithm of 6 divided by 200 divided by 0.04 multiplied by logarithm of 2. Let's see if we can find the approximate value of that. Here is my calculator. Then we have logarithm of 6 divided by 200 divided by 0.04 multiplied by logarithm of 2. Then we got negative 126.5 actually, but at approximately 100, negative 126. Okay, let's try another. Find algebraically the exact points of intersection of y is equal to e raised to x minus 3 and y is equal to 1 minus 3 times e raised to negative x. Check your solution using technology. Let's solve first algebraically. Then we have e raised to x minus 3 is equal to 1 minus 3 e raised to negative 3 negative x. As you can see, there is a negative exponent there. I don't want negative exponent right now. So if I'm going to multiply both sides of the equation or all the terms of the equation by e raised to x, then I have e raised to x multiplied by e raised to x subtracted by 3 multiplied by e raised to x is equal to 1 multiplied by e raised to x subtracted by 3 multiplied by e raised to negative x multiplied by e raised to x. And we know that this is 1 because e raised to 0 Then we have e raised to 2x subtracted by 3 raised to x is equal to e raised to x minus 3. So if we subtract both sides of the equation by e raised to x and add 3, so e raised to x and add 3, then we know that this is 0, this is 0. Then we have e raised to 2x subtracted by 4x. We have 3 there and we have 1 there, added by 3. E raised to x, I should say, is equal to 0. It's easy to see if you assign e raised to x, sorry for that, as a, for example. So we have a raised to 2 subtracted by 4a added by 3 is equal to 0. And we know that this is already a quadratic equation, where if I'm going to factor that with -3 and -1, then I will get -4. If I will add them, and if I multiply them, then I will get +3. So I have a minus 3 and a minus 1 is equal to 0. Now it's time to substitute the value of a, which is e raised to x minus 3 multiplied by e raised to x minus 1 is equal to 0. Then solve each of them. E raised to x minus 3 is equal to 0. And then we have e raised to x minus 1 is equal to 0. Then e raised to x is equal to 3. Then we have x ln of e is equal to ln of 3. And then we have e raised to x is equal to 1. Then we have x ln of e is equal to ln of 1. This is 1. Then we have x is equal to ln of 3. And this is 1. Then we have x is equal to ln of 1 is 0. So that means they have points of intersections when x is equal to ln of 3 and y is equal to 0. Let's see if we can see that using our calculator. Okay, I prepared it already, but if you want to see how I did it, then I have here, exit, my first graph, e raised to x minus 3, and my second graph is 1 minus 3 e raised to negative x, and then draw. As you can see there, it is there. If you want to see the point of intersections, then I have here now intersections. When x is equal to 0, then y is equal to -2. We are right with that. And the next one is when x is equal to 1.09, that is, I hope that is ln of 3. Let's see if that's correct. And y is equal to 0. Let's see if that's correct. Ln of 3, ln of 3, 1.09. That's true. Okay, then we got it. In my next video or series of video, I will be discussing the change of base rule with examples. See you around, and thank you for watching. I hope you learned something, and please subscribe. Have a nice day.